Welcome to James Watt Thoughts. Today we'll start the term equilibrium. Equilibrium means it's a state of balance between the equal opposite forces or actions. Something we can say the part or the system is totally in stable condition. Okay. In other words, we used to call it as equipoise or stability, but normally in thermodynamics we used to call it as equilibrium. There are different types of equilibrium available. One is mechanical equilibrium, second one is thermal, and third one is chemical equilibrium. We'll see one by one. First, what is mechanical equilibrium? When no mechanical work is done by the system. It means, suppose we take an object of X in which the force is acting from the upward side as F1 and downward side as F2. When both the forces are equal, then nothing will happen in the system. No mechanical work will happen in the system. Such conditions will be called as mechanical equilibrium. In other words, we can take it as like net external force acting on the body is equal to 0, or net equal torque acting on the body is 0. Basically, for easy remembrance, no imbalance forces on both sides. Next one is thermal equilibrium. When there is no heat transfer happens between two different systems or systems to surrounding or surrounding to system, such case will be called as thermal equilibrium. Suppose let us take a system A and B. When both are in the same temperature, there will not be any heat transfer. If suppose this system is in 50 degrees centigrade and the second system is 0 degrees centigrade, means if you are keeping next to each other, then there will be a heat transfer from here to there, A to B. For easy remembrance, we can tell that no change in the temperature. And the third one is chemical equilibrium. Chemical equilibrium means, suppose we will take a reaction, this is a reverse reaction and this is a forward reaction. Okay. At a particular point of time, when both meets, from there the equilibrium state will start. Suppose we'll take some chemical reaction is happening between two different systems. Okay, when the reverse and forward, we can say like one is acid and second one we are trying to dilute it. Okay, after the required level of dilution has happened, there will not be any change in the chemical reaction. That stage is called as equilibrium state. No change in the chemical composition between the systems with respect to time. Then we are coming to the major part, that is thermodynamic equilibrium. Thermodynamic equilibrium is a state in which all three, mechanical, thermal and chemically equilibrium, when all three are put together, it is called as thermodynamic equilibrium. Okay. Now we'll go to the Zeroth law. Why this law is called as Zeroth law, whereas in other areas and all only first law, second law will come. This law is something like a basic law which has been identified or stated after the first and second law is being stated. So they don't want to confuse the future generation. Hence they named this as a Zeroth law. Okay, let us see what is Zeroth law of thermodynamics. When a body is thermally equilibrium with two other bodies, then those two bodies are also thermally equilibrium to each other. Suppose we'll assume three different systems or three different bodies, A, B and C. Suppose if the A is thermally equilibrium with B and C. It means B and C is also thermally equilibrium. Okay. Suppose we'll take it like this. 50. Suppose A is 50 degrees centigrade, B is 50 degrees centigrade, and C is 50 degrees centigrade. If we are just trying to state the system, state the law with A as a reference and B and C, and we are telling that these two also will be thermally equilibrium. Okay, I'm stating once again the system. When a body is thermally equilibrium, when a body is thermally equilibrium with the two other bodies, then those two bodies are also thermally equilibrium with each other. Okay, thanks. Thank you, friends.